All right, if you're watching this video, you're probably trying to get some help with sequences on 13.1, or we're taking the state assessment. At any rate, this is a pretty interesting topic, and 13.1, 13.2, and 13.3 are all on sequences and then series, and there is a difference between the two. So let's first talk about sequences. The notation of a sequence is A sub 1, A sub 2, A sub 3, and so on, and it's dependent upon this number right here. First term, second term, so on. A to the n, A sub n, means the nth term. And here's some examples. 0, 1, 4, 9, 16, 25, that is a sequence of squares of integers. 2, 4, 8, 16, 32 is a sequence of positive integer powers of 2. 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, so on. This is a simple one. 3, 1, 4, 1, 5, 9, and just keep going. That's the sequence of digits in the decimal expansion of pi. All right. 3.9, 5.3, 7.2, etc. That's the sequence of U.S. population in millions from census reports from 1790 to 1880. So you can see these are just what we call sequences. Now, here is some notation that we have to understand. Let the first 5 terms of the sequence A sub n equal f of n, where f of x equals 500 minus 10x. So A sub 1 then is 500 minus 10 times 1, which is 490. A sub 2 is 500 minus 10 times 2, which is 480, etc. But they're listed A sub 1, A sub 2, A sub 3, A sub 4, and A sub 5. So we must understand this notation because we're going to first talk about arithmetic sequences. And I know you're going to say arithmetic sequences, but for some reason we don't pronounce it that way. They are called arithmetic sequences. So to find the nth term, that's this one, any term, we're going to take the first term plus the number of terms minus 1 times what we call the common difference between consecutive terms. Common difference, D. So all that means is to find any term number, we're going to take the first term and add it to the number of terms minus 1 times the common difference. So for example, which one of these sequences are arithmetic? So 9, 5, 1, negative 3, negative 7. Well, let's see. We have a difference of 4, minus 4, minus 4, minus 4. Okay. So we have a common difference. So if we want to find the formula, we would have D equal to negative 4. A sub 1 is 9, right? 1, 2, 3, 4, 5, and there's 5 terms. So we could find any number of terms using this formula. Okay, so that is arithmetic. Is this one arithmetic? Well, it goes up by 3, 6, 12. No, it's being multiplied. It's got to be a common difference. Let's see. C is 2, then 2 plus P, then 2 plus 2P, then 2 plus 3P. What are we adding each time? P. So therefore, that is an arithmetic sequence. How about this one? Minus 5, looking good so far. Plus 5, plus, nope. You can't change in the middle of the game. If it's minus 5, it's got to be minus 5 the entire time. So yes, yes, no, no. Those are not arithmetic. Okay? Now, here's where arithmetic sequences get interesting. Arithmetic sequences, guys, are really just linear functions, and they can always be changed to y equal mx plus b. For example, Write a formula for the general term of the odometer sequence of the car that's driven 8,000 miles per year and had gone 15,000 miles when it was bought. Okay, if we're going to do the arithmetic sequence, that is a sub n equals a sub 1 plus n minus 1 times d. Well, a sub 1 is 15,000. The common difference is 8,000. So this is our formula. Okay, that makes perfect sense. Then we want to know, what is the car's mileage 7 years after its purchase? Well, if we're going to do 7 years after its purchase, then it's the 8th year. So n is 8. So we're going to take 15,000 plus 8 minus 1, which is 7, times 8,000. It has 71,000 miles. Now, notice, the formula for the nth term can be simplified to this, which is a linear equation. Because if we distribute the 8,000, we end up with this formula. So it's just a linear function. So when you see arithmetic sequences, you know they are going to be lines. The next type of sequence is called a geometric sequence. Now, I don't know why it's called this, because it has nothing to do with geometry. And if it does, it's physical geometry, which we're not really talking about here. It's a geometric sequence because it's a common ratio. So instead of adding a common difference or multiplying by a common difference, this is simply multiplying by a common ratio. And this literally is our formula. A sub n equals the first term, a sub 1, times that ratio to the n minus 1 power. So you can find any term using this formula. So, which of these are geometric? Let's see. 5 times 5, 25 times 5, 125 times 5. That's geometric because the common ratio is 5. How about this one? Ooh, divide by -2 or multiply by -1/2, -1/2, -1/2, -1/2. Yep. Common ratio is -1/2 or -0.5. How about this one? Divide by 2. Oops. Nope. That's 2/3. Nope. So this is not, because there's not a common ratio. Okay? Now, here's an example of geometric sequences, and they should look really familiar because they're nothing more than exponential functions. Write a formula for the general term of the salary sequence, which starts at 40 grand and increases by 5% each year. What is your salary after 10 years on the job? So your A sub 1 is 40,000. So your increase is 0.05, so your ratio is 1.05. Look familiar? So here's your formula. So that is nothing more than the exponential formula. That's it, AB to the T. Now, after 10 years, we'll be starting our 11th year, so we put 11 minus 1 in there, and that is 10, and so our salary would be $65,156. And notice how it just looks like AB to the T. So arithmetic sequences are linear, and geometric sequences are exponential. Now, don't worry about this due Friday business. Whenever we get to this, I don't know when we get to this, but this is our problem set, page 539. It is rather lengthy. Please put your head down into your book and start